Right, you're here watching this video because gosh darn it, your teacher is expecting you to be able to do the substitution method, solving a system of equations, and it's not easy. You probably watched them do a lesson, you went home, you started your homework, and you were like, what do I do after this? What do I do after that? There's a lot of steps involved, but I believe in you. You can do this. Let's get it done. Okay, so I'm going to start you off with an easier system, and then we'll make our way into more challenging ones. I'm going to do 3 examples in this video for you, so stick with me, and by the end of it, you're going to be a pro. All right, what you have to understand about systems of equations is we are trying to find an x value and a y value that would make both of my equations true. Not just one of them, but both of them have to be accurate when I plug these 2 numbers in for x and y. We're just replacing these numbers with x and y, and it should come out to -10. Replace those numbers with the x and y's, and that should be equal to whatever y is. Okay, so what do? The substitution method is exactly what it sounds like. You are substituting something in place of another so that you can solve. The problem with solving for x right now or for y is that we have another variable in the equation. So 2 variables. You can't solve with 2 variables, but you could break it down to an expression on the other side of the equal sign. Okay, why is this one the one I'm starting you with? I told you I'm going to start you with something easy. I think this is an easier system. Why is it an easier system to solve? Because y is already by itself. It's already isolated. So I always tell my students to put a box around the expression that is equal to a variable all by itself. Notice on the left side of the equal sign, y is the only thing you see. It's isolated. So y is no different than a -8 times an x plus a 2. Okay? So down here on this second equation, what do we have? We've got a y right there. But we want to create an equation here that only has x's. So I want to change y to something else. Well, y is the same thing as this, and this is an x instead of a y. So if I can just erase this y and replace it with this information, I'll have an equation I can solve for. Okay, so step 1 in a problem like this is take the expression equal to the isolated variable and put this expression in place of that variable on the other equation. So because this is equal to y, I'm going to change that y to -8x plus 2. This is now that. So everything else just needs to come down. That's a 2x. This is a equal sign, -10 or -10. So now that I have that written out, I've got an equation that no longer has y's in it. We substituted something in its place. We substituted something with an x in it. So now what I can do is I can say 2 minus 8x, and I can just solve this equation for x. So you've done this since the beginning of algebra. 2 minus 8 gives you -6 with an x attached, plus 2 comes down, equals -10. Now we're in a 2-step equation. Subtract 2, -12, -10 minus 2, -12, equals -6x. Divide by this -6. Divide by a -6. This is just inverse operations. You should know this already, okay? And what's a negative divided by a negative? Positive. So we're finding that x has to be 2, okay? Now remember, our solution is not just one number, but it's an x and a y. We only know x right now. This is where the substitution method and solving a system becomes a little tricky because you're so used to solving for x, right? You used to just get x equals a number, life was good, you moved on to the next problem. We can't do that anymore because we need a coordinate, we need an ordered pair, an x and a y value for each part that's missing. We have 2 missing pieces of the puzzle in the system. We got to find both of them. At this point, we've only found one. Once you find that first missing puzzle piece though, life becomes a lot easier. X is 2. So go back to your original 2 equations I don't care which one you use. I tell my students, just pick the one that looks easier to plug the number into. If x is 2, why would I say negative 8x? Wouldn't I just say negative 8 times 2 now? Because if x is there, and I know x has to be a 2, change the variable to the number now, okay? So let's do that. Let's say y equals negative 8x plus 2, but instead of an x, I'm gonna erase it. I'm gonna put the number in that I found x to be. Remember to put them in parentheses to avoid mistakes. Negative 8 times a 2 is a negative 16 plus a 2, and a negative 16 plus 2 would give me negative 14. So y would have to be negative 14. Well, now I know what x is, I know what y is. I've found everything I need to give the solution to this system. The original system solution would be 2, negative 1, or negative 14. Keep in mind, another method of solving a system is through graphing. We're not doing that in this video. That's another method you could use. But if I were to graph this line and this line, they're going to intersect, they're going to cross paths at 2, negative 14 on a graph. That would be somewhere about 2 over 14 down. So somewhere down here, those two lines are supposed to intersect. Hopefully that makes sense, okay? Now we're going to move into a problem that's a little bit trickier because the variable isn't going to be isolated. I'm going to make you isolate the variable first. How would I do that? I could give it to you in a different form. So let me erase this and get that ready to go for you. Okay, I did that thing that teachers do where we make the problem harder and then all of a sudden you're like, well, what do I do now? Exactly, okay? What do we do now? We've got this equation and this equation, and we need to solve for x and y that would make both equations true. Meaning if I put the same number here for x as I do here, the same number for y here and here, they both should come out to 23 and negative 20 to be accurate equations. Step 1, last time we had a y all by itself, so we put a box around the other side. Do I have a variable all by itself, an isolated variable in these two equations? The answer is no, okay? If you look at y, it's got all this over here with it on the left side of the equal sign. If you just look, the x's and y's are all on the left, so nothing's by itself. But this x has no number, no coefficient attached to the variable. It's just x. So if I can take that term right there and get it over to this side, x will be all by itself. So let's do that. Step 1, isolate a variable. So we're going to take away 4y, take away 4y. Those aren't like terms, so don't you dare try and put them together. Just keep them separated. X is negative 4y. And I'm negative 20. Now I have x by itself. When we get the variable by itself, put the box around the expression on the other side. This is what we want to use now. We need to substitute negative 4y minus 20 in for x, but on the other equation. We've already used the bottom. Remember, these are two equations. 1, 2. Because we isolated x on the bottom equation, we need to take this expression and put it into the top equation. Where do I want to put that information? It's the same thing as an x, so it needs to go right there where x is. So 2 needs to multiply by all of that. So how would I write that? 2 parentheses, and now you need to put this in. 2x is now 2 times negative 4y minus 20 minus y equals 23. Equals 23. So notice, this expression is the exact same thing as this expression. The only difference is the x is this information right now. And the reason I got to do that, so you have an understanding of why we go about all this craziness, is because now if you look at my equation, do I have any x's? Nope, they're all y's. And when you only have one variable, we can figure out what the variable is. We can say y equals this number. Let's do some work and figure out what number it is. I'm interested. I'm intrigued. 2 times negative 4, that's a negative 8. Make sure the y stays attached. 2 times negative 20. Positive times a negative is a negative. 20 times 2 is 40. Bring down negative y. 23 comes down. This term and this term are what we call like terms. Could you figure out why they're alike? Yeah, they both have y. Okay, so -8 minus, if you don't have a number in front of the variable, it's really just worth 1. So this is -8 minus 1, which is -9. Keep the y attached. -40's got to come down. It's equal to 23. Then I got to take plus 40, cancel, plus 40. 23 plus 40 is 63. And I got a -9y. And I get excited because I know 63 divides by -9. Nice and neat. We're going to divide by -9. Divide by -9. I'm not going to get any decimals or anything here because 63 divided by -9 is negative. Make sure you pay attention to that. A positive divided by a negative equals a negative. And how many times does 9 go into 63? 7. There we go. So we know our solution has a y value of -7. But there's still a missing spot, Mr. Bielik. Yeah, I know. We haven't figured out what our x is yet. So we're going to use our y value to find our x value. Now the last and final step, usually probably one of the easier parts of this problem, is just taking this number, putting it either there or there. I think the top one's going to be easier to work with, so I'm just going to say 2x minus y, but instead of y, I'm going to say minus -7. Instead of minus y, because my y value is -7, say minus -7. Okay, let's do that. 2x minus the y value, which is -7, should equal 23. This equation only has x in it, so we could solve for x. Subtracting a negative is no different than just adding. Now I got a two-step equation where I subtract 7. 23 minus 7 is going to give me, I actually had a tough time thinking about that one for a second. That was weird. Okay, 16. Divide by 2, divide by 2. X is equal to 8. So we know 8, -7 is the point the two lines would intersect. We know that if we put an 8 in for x here, a -7 in for y there, it would come out to 23. We can even prove that right now, just real quick. 2 times 8, my x is an 8. Actually, my ex she was kind of annoying, but you get it. Okay, x is 8, and then y is -7, so minus y, so minus -7 is supposed to equal 23. Let's check it. 2 times 8 is 16. Subtracting a negative is like adding. What is 16 plus 7? 23. We're good. We checked. Everything seems to match. Okay, why was this one a little bit more challenging? The reason this problem was more difficult was because the first step wasn't done for you. You had to take that x and get it by itself first. So step 1 is always isolate a variable so you can use the expression on the other side to plug into the other equation. All right, let me erase this and get a new one up for you. And last but not least, we got this problem here. What makes this problem more challenging is we don't have an isolated variable right out the gate. That y's got a -9 attached to it. The x has got an 8 attached to it. The y's got a 5 attached. The 8's got a -8 attached. So every one of our variables has a coefficient. So we got to just ask ourselves, like, which one's going to be easiest to get all alone? Which one of these is going to be the easiest to just break down and get by itself? So there's a lot of things we could do here with this problem. It's not going to be easy no matter what, but I think we could probably isolate this y pretty easily. Okay, that's just what my eyes and my gut is telling me. Let's isolate this y. So that's what I'm going to do. I'm going to say 8x equals 5y. plus 24. My main goal, my main job is I got to get a variable by itself. So let's just start by doing that step. We're going to do a line down the middle. I got to get y all alone, so I got to get rid of 24. So we're going to subtract 24. Subtract 24. Now I've got 8x minus 24 equals 5y. I'm going to divide by 5, divide by 5, divide by 5. Okay? Now there are a couple things you can do here because these fractions are not going to come out nice and neat. We can just convert everything to a decimal if you wanted to do it that way. If you want to work with fractions, work with fractions. It's totally up to you. So I haven't really shown you any decimal work here, so let's just do decimals. Just 8 divided by 5 if you want to turn that into a decimal. We all know that's going to give us 1.6. So boom, just plugging and playing. This tool helps you when things get like this. So 1.6x. Negative divided by a positive is a negative. 24 divided by 5 is going to give me what? How many times does 5 go into 24? 4 times. Okay. And then you're going to get a 0.8 after that because there's only 8/10 left. Just to prove it to yourself, go grab it. Say negative 24 divided by 5. Check it. So do mental math. I always want my students mentally thinking these problems through, using their number sense, but I also want them to put their seatbelt on, right? Check it. Same thing as a seatbelt. We get in a car, put a seatbelt on just in case something happens. We check our calculators just in case something weird happened in our thoughts. So 5 divided by 5 goes away. Now we've got y all by itself. Remember, I want you to put a box around the other side. This is something that I started teaching about 3 or 4 years ago. Ever since my kids started putting boxes around it, they got a lot better with this skill. Okay, so this information is the same thing as a y. I need to go to the new equation, the one I haven't used. I used the top equation to get this. So I need to put this information into the bottom equation. Now notice that y is what this is. So I need to take all this information and put it where the y is in the other equation. So negative 9 needs to multiply by all of this. So here we go. Negative 9 times all of that, 1.6x minus 4.8 equals 40 minus 8x. Now you got variables on both sides. You have to be pretty strong with your solving multi-step work because that's what you're going to be doing in your last couple of steps, solving using substitution. So again, this should be review. This should not be something you struggle with anymore if you're dealing with systems now. If you are, you're going to need to go back and get some extra work in with solving equations. I've got plenty of videos online. You can watch those for help if you need it. Okay, now we're going to go negative 9 times 1.6x. Negative 9 times negative 4.8. Grab that calculator to make it quick. So negative 9 times 1.6. That's going to give you negative 14.4. Negative 14.4 with the x attached. A negative times another negative is going to make a positive. So 9 times 4.8 is just going to give me a positive 43.2. Nothing's going to change over here. Okay, variables on both sides of my equation. Let's add 14.4x to get all my x's over here on the right side. Add 14.4x. So negative 8 plus 14.4 is 6.4. So now you got 6.4x. It's a positive, right? There's more being added to a negative than we had. 40 comes down. Equal sign comes down. 43.2 comes down. And now we've got a two-step equation. Take away 40, take away 40, leaves you with 3.2 equals 6.4 with an x attached. We need to divide by 6.4, cancels, divide by 6.4. Okay, you can do mental math, but then again, remember, it doesn't take that long to just grab a calculator, 3.2 divided by 6.4, and you're gonna get 0.5. The reason I tell you this is because I'll have kids will get to here and they'll say the answer is 2 because they're thinking this number divided by that number. Your calculator, as long as you type it in correctly, is gonna give you 1 for x. So now that we know that x is 1/2, our last and final step is just plug 1/2 into one of these two equations and solve for it. Okay, so I'm going to erase this section over here. I'm going to change 1/2 to a decimal. So we could say x is 0.5. So 8 times 0.5. 8 times x is now 8 times 0.5 is equal to 5y plus 24. Again, now I have an equation with just a y in it. We already know my x is 0.5. Now we're about to find the y. Half of 8 is 4. 5y plus 24. Two-step equation. Take away 24. Take away 24. That's going to give you negative 20 is equal to 5y. We're going to divide by the 5. Divide by the 5. Y equals negative 4. All right, you've gone through 3 systems of equation problems, all being used or solved with the substitution method. Sorry, that got erased. Okay, substitution method takes time and it takes organization. If you look, everything I have is nice and clean. If you're going to do all of these steps to solve one problem, you can't be scattered all over the place. You're going to lose your work and you're going to get lost within what you're doing. Take your time, keep yourself organized, and you can take care of substitution method with ease. It's going to take practice, study hard, and good luck on your upcoming test.